What do quadratic equation roots mean with the discriminant? Imagine you're trying to find where a roller coaster track touches the ground. The roots of a quadratic equation tell us exactly where that happens on a graph. The discriminant is like a quick check to see how many times the parabola crosses the x-axis. When you see a quadratic equation written as x squared plus bx plus c equals 0, the roots are the values of that make the equation true. The discriminant is calculated using the formula b squared minus for times a times c. This number helps us understand the roots without solving the whole equation. If the discriminant is positive, it means there are two different real roots. So the parabola crosses the x-axis at 2 points. Think of it like a roller coaster touching the ground twice. When the discriminant is 0, there is only one real root. The parabola just touches the x-axis at 1 point, like a coaster that barely grazes the ground. If the discriminant is negative, the roots are not real numbers. Instead, they are complex or imaginary roots, which means the parabola does not touch or cross the x-axis at all. This is like the coaster flying above the ground without ever touching it. Knowing the value of the discriminant helps us quickly tell how many solutions a quadratic equation has and what kind they are. It connects the algebraic formula to the shape of the graph, showing us where the parabola intersects the x-axis. This is useful in real-world problems, like calculating the time a ball hits the ground or the maximum height of a projectile. It also helps in graphing because it shows how many times the parabola will cross the x-axis. By understanding the discriminant, you can analyze quadratic functions faster and more confidently. It's a simple way to see the nature of solutions just by looking at the coefficients. So, next time you see a quadratic equation, remember that the discriminant is your quick guide to understanding its roots and how the graph behaves.